everyone, welcome to On Track, an ongoing video series where we cover hot topics in PCB technology. My name is Andy, and I'll be your host as we dive into the latest industry trends and emerging developments in PCBs. With electronics getting smaller and smaller, not to mention the Internet of Things, IoT, really shaking product and service design up, the pressure is on for PCB designers. PCB design requirements are becoming more and more advanced. New development projects, especially IoT and wearable electronics, are demanding smaller, faster, and more flexible boards. Designers need to stay ahead of the curve. In today's video, we'll cover a few of the strategies and practices that will keep you ahead of the pack. More than anything else, you'll start to see how an integrated approach combining disciplines works best for these next-generation devices. There's no denying that PCBs are constantly shrinking. These days, the electronic wizardry is taken for granted by the end consumers that demand ever sexier and industrial designs, and the PCB designer is left with an ever-shrinking envelope to design into. Of course, power and performance requirements keep going up in spite of that, but thankfully, new design-shrinking solutions are keeping the pace. You probably know that efficient fan-outs and blind buried vias are two techniques that take advantage of smaller integrated circuits, especially ball grid array and quad flat package units. These types of ICs are essential for powerful but space-efficient PCBs. Designers can also take advantage of high-density interconnect boards, but be prepared to use blind buried vias for those as well. Just because your PCBs are getting smaller doesn't mean that they can start getting slower. No. Wearable devices especially are demanding smartphone-like performance, and the range of IoT devices and services aren't far behind, putting greater demands on your PCB design. Now, this is especially true with current silicon transistors nearing the minimum size limit. Mastery of space efficiency techniques will be essential, but you knew that already. You'll also want to pay attention to the ever-improving specification of new ICs, specifically those that combine many features into one single package. It's no wonder that many IoT products are rallying around system-on-chip ICs to really cut down on component count. Of course, this is another double-edged change that can create new thermal issues. Once again, I implore you to keep track of your heat analyses. It also pays to consider non-traditional board substrates like ceramics that offer superior heat dissipation. For some highly integrated ICs, radical changes like these might be the best strategies. Similar to space management, PCB layout also plays a big role in performance. For example, you can minimize inductance between capacitors and the components they power by keeping the two located close together. Long, thin traces and vias also create inductance, reducing board performance. Lastly, flood all unused PCB areas with a ground plane, but watch out for springboards. Isolated copper. Having an easy-to-use power delivery analysis tool that operates within your PCB design environment is essential if you want to avoid design stoppages while you wait for simulation results from an expert. According to statistics published in 2015, there will be 34 billion connected devices by 2020. Unsurprisingly, every one of them will have a PCB. That means that eventually there's going to be a lot more PCBs thrown away. Consumer products especially are viewed as disposable, and thanks to IoT, more PCBs than ever before are likely to get tossed out. We've talked about a lot of techniques and strategies in today's video, but there's only one that's completely foolproof: training. PCB design is a process of continuing education. Of course, for many designers, this means research and practice on a mostly individual level by taking courses and staying ahead of new trends with industry blogs, videos, and trade show demonstrations. However, your extracurricular efforts should be supplemented by structured training as well. Working closely with experienced colleagues, especially those already working on more challenging projects, like IoT, will really get your skills up to speed. After all, public electronics publications are reporting a skills shortage in the industry, a problem magnified by rising design complexity. Open some communication with your manager about skills development, and you'll probably discover a wealth of information right in your own workplace. Today's video probably gave you a lot to think about. Next, take advantage of the wealth of resources, videos, blogs, articles, and white papers at our Learning Center. We want you to be equipped to deal with any type of PCB project, so we're delivering content to help you stay ahead of the learning curve. Thanks for watching. Until next time.